Once you have your block template built, you're ready to start hunting for the last piece of data that will turn your block template into a real block, the nonce. The Bitcoin block header is data that, when hashed, returns a random number. We need this random number to be less than the block target number. Putting data through a hash function is a lot like drawing a bingo ball or rolling dice, hoping to get a value beneath a certain number. It's a random process, and which number you'll get after you hash data isn't something you can know ahead of time. You have to hash the data in order to find out what the result is. You're like a searcher who's seeking the right set of block header data that, when hashed, will give you a low enough winning number. The first node that finds the right set of block header data that, when hashed, gives you a low enough number, wins that block. In order to find the winning hash, you'll need to slightly change the block header data and hash it, again and again and again. The data that we change every hash attempt is the nonce field. We'll start at 0 and work our way upward until we either run out of nonces or we find a nonce that gives us a winning hash number. You'll notice that we also include the hash of the previous block in the data that we're hashing. This is what creates an unbreakable chain of blocks. We build each block hash using the block hash of the previous block. Once you find a winning nonce, you'll want to write down the nonce onto your block header. You'll also want to record the hash of the block somewhere. This is what you'll use to refer to the block you just found. A winning block hash is one that's less than the target written on the block header. We probably won't find enough blocks in this LARP to change the target, but in the real world, not in the LARP, the target number gets automatically changed every 2016 blocks. This is approximately every 2 weeks. In the LARP, we'll update the difficulty every 10 blocks. It's very likely you won't find this many blocks during the LARP game today. In the LARP, we'll use our basic machines to try lots of nonces very quickly. If your basic finds a winning nonce, you'll want to write it down and start notifying other nodes on the network about the new block you found. As new blocks get added to the chain, we'll promote transactions from being candidates to being mined in the mempool, up to transactions that have been confirmed in the UTXO set. All right, let's mine for the next block. Good luck! Let's mine. Take your block header from your block template and type the information into your basic miner. When you come to the nonce field, we'll leave it blank or enter in 0. This will tell the miner that we want it to hunt for it. Once the data is input, we'll let the miner go until it finds a winning nonce. It may take several minutes to find a winner, so be patient. Good luck! When a winning nonce is found, your miner will stop on the winning nonce value. Write this down on your block header. After this value is written down, hit the pound key on your basic to advance to the next screen. This will show you the block hash for your winning block. Notice that it's less than the target value. I'd recommend writing this down somewhere so that you have it for later, maybe on the block header card somewhere. Once you've found a winning block, your next job is to tell the rest of the network about your winning block. You'll want to be fast and get your block out across the network quickly so that other miners will start building on your block and stop trying to find another block at the same height. Let's tell the other nodes about your block. To let another node know about a block that you have, you'll need to use network messages. We'll use the I have block and send block messages to get blocks out across the network. To tell your peers about a new block, find the I have block message. Fill this in with the block hash of the block you just found and send it out to all of your peers. You'll want one network message for each peer connection. If you receive an I have block message and don't have that block, fill in a send block message and send it back over the network connection to the peer that has that block. After you get a send block message back, you'll want to send your peers a copy of the block you just found. To do this, you'll need a new block envelope, a blank block header card, a copy of your Coinbase transaction, and a copy of the Compact Block Transaction ID card. Make a copy of all this data and then send the block copy to your peer over the network using the network header rings. Your peer, once they get the transaction, should use the block validation checklist to validate the data for the block. After you've validated a block, we need to extend the blockchain. We'll need to update our UTXO set to include the transactions that are inside this new block. Add the Coinbase transaction in the new block to the UTXO set. Find each transaction listed on the block's transaction ID card. For each input listed on these transactions, cross it off so it no longer is valid to spend again. Once you've done this, move the transactions into the UTXO set. Finally, put the block into your blockchain and send out a network message to your peers to let them know about the new valid block that you now have. If you are mining, you should stop mining and try to extend from the newest block. You may need to update your Coinbase transaction, list of transactions in the block, and block headers so that you're now building on the right chain and not including any transactions that have already been confirmed in your block. Once the blockchain has been building for a while or time runs out, it's time to make the final score of the game. For this, you'll need the node scorecard and master scorecard. Have each node do the following to score their UTXO set. On their node scorecard, place an X next to the color of their private key. For each output in their UTXO set, which isn't marked off, have them count up each other key's amount. This is the amount of Bitcoin that each other node owns in their blockchain, who will add each scorecard to the master scorecard. Turn the node scorecard into the facilitator, who will add each scorecard to the master scorecard. Add up each of the rows for each node on the master scorecard. The node with the highest balance across all UTXO sets, which wasn't their own, is the winner. Congrats! It's likely that this was the luckiest node, but it's also required for them to send out their block data to as many other nodes as possible. This wraps up Base 58's world-famous Bitcoin LARP. I hope you learned a lot about how Bitcoin works.